Here we are in the tutor training video on lines. So let's consider what lines are and how they work and where they actually came from. The first thing to note, and this will help your students tremendously with everything they're trying to do, is when you have an equation that has two variables in it, like x plus y equals 9, the whole goal is to find a solution, something that works. But notice when you do this, you say, oh, x equals 1 and y equals 8 is a solution. It has to join together. That is why they put parentheses around it and connect it, because when you have x equals 4 and y equals 5, you can't have that 1 and that 5 go together. So the parentheses join them together and make it a coordinate. An ordinate is just something that puts things in order, and so numbers are ordinates. So instead of writing this all the time, we write 1, 8, 4, 5 in alphabetical order. That will help him. The next thing is that there are infinitely many. You can't go wrong. There are billions and billions of points on this line. So when we start talking about points, we're talking about two things, like in Battleship, C5 or H2. You can't just have 1, 7, or H and make it work. So you need two numbers to make an answer, and every point is an answer. So when you start graphing these, you're like, oh, 1, 8, clear up there, and 4, 5 over there. Every one you start doing forms a pattern. So how many do you actually need? Well, you only need 2, but you do need at least 2. Oop, there we go, I almost got it, to go like that. So when you are graphing a line, you need to find 2 points. That's really what is absolutely necessary. You need 2 points. There are 3 ways of getting the 2 points. First one, pick and stick, or choose and cruise. So step number 1 on pick and stick, pick a number, any number. Step number 2, stick it in for one of the variables. You may stick it in for the y, stick it in for the x, it doesn't matter at all. And step number 3, solve for the other one. Solve for, I'm going to call it the partner. Yeah, you know how this works. Over here, if you take 18.3 and say, I want to stick that in for the x, then you stick it in right there, and you have 18.3 plus y equals 9. And really help your students understand that they get to pick anything if they're doing this method at all. Solve for the partner, and then connect the dots. And that's it. So they do this to get the 2 points. Here, notice that when they get to this point, they're back to solving an equation. And this is one of the nice ones that they know how to do. So there we go. That's the first one. The next one, intercept. An intercept means to cross. So where this line crosses the x-axis or the y-axis, those are intercepts. So the x-intercept happens when y is 0, and the y-intercept happens when x is 0. So notice that if we go 0 here and then up or down, there's the y-intercept. So step number 1, pick 0 for x. Okay, step number 2, pick 0 for y, and that's how you get your 2 points. Now, is it possible that it'll go through the origin? Absolutely. Then you'll only get one of them and you have to revert back to this. So the third way of graphing is using the slope. So we've got to talk a little bit about slope right now. Many people misunderstand what slope is. Slope is just a number that says how steep the line is. That's all it is. And people be like, oh, I know that. There's a formula, m equals y2 minus y. Well, yes, that formula helps you to find slope, but slope itself is a concept. It's its own independent thing outside of a formula on how to find it. Now, a good way to introduce this is many people will have seen a road sign. Yeah, like that. And then the truck up here. There we go. Look at that nice, beautiful looking truck. Okay, and it says something like 7%. Well, what does that mean? It means 7 per divided by 100. And that's what it's actually talking about. This is a ratio of how much it went up and down to how much it went across, rise over run. You guys have seen that before. And what this causes, yeah, if you cut it in half, It went 100 feet here, and it went up 7 feet. Well, if it goes up 8 feet, it's a little bit bigger, up 9 feet. So bigger numbers here mean steeper slopes. That's good to know. And yes, it gets you the formula. The way you get the height is you subtract the y's. So that's the difference. That's where you get the y2 minus the y1 over the x2 minus the x1. Okay, good. So that helps us understand where that formula came from, not just that it fell out of heaven. So if I write something like y equals 2/3 x plus 5, there's something that's really cool that students will be able to see. Obviously, you're going to say y equals, this is the slope, and that's the y-intercept. Many can write it as y equals slope x plus yent. You guys will probably have recognized as y equals mx plus b. What does a b mean? What does an m is? Well, m is for slope, mountain slope. Well, before going to this, there's something that you can help students discover, which is amazing to watch. It really is one of the coolest things. If you were to take and find 2 points, let's find an easy one. If 0 goes in for x, what's y? Yeah, it's 5. It's an easy one, and they've done that before, finding intercepts. Now let's find another easy one. What could we times by 3 here? Let's do like a 3. Hey, look at that. 2/3 times 3 is 2 plus 5 is 7. Now what if I found the slope of these 2 points? 7 minus 5 is, let's put that up there, and 3 minus 0, that's 2/3. Oh my word. Okay, this is a relationship, and students can discover this. It does not need to be told to them. And helping them to discover that this relationship actually exists, and they don't have to go through that whole process, is amazing, because it allows them to use this shortcut in this relationship to say, hey, I can do y equals mx plus b, or y equals slope x plus yent. I have a point right there. I have the intercept. Good. And then the second point, I use the slope to find it. So on this one, 0, 5. Now, the y-intercept is more appropriately said 0, 5 than just a y-intercept of 5, because every point on here is a coordinate. Now, technically, it's not incorrect because intercept means to cross, but it will help the students to understand it's 0, 5. 0, 5 that makes it work. And then the slope of up 2 over 3, that's where we get the up 2 went to 7, and the over 3 went to the second point. Now, they don't have to write down those other coordinates. All teachers will accept that slope, but they could actually go up 2 over 3 again. Hey, that's 6, 9. Up 2 over 3, 9, 11. All of these points will work in there, and the slope becomes something to help them find the infinitely many points that are there. One final word about slope that everybody should know. A slope is a number that measures the steepness. So smaller numbers like this, that's about a 1/2, meaning it's a 1 to 2 ratio, rise to run. If we go smaller than that, you might have a 1 to 3 ratio, and pretty soon you'll get exactly flat, which means the numbers have gone to 0. Well, when you start going down this way, that means you're down to over, -1 to a 2 run. That is a negative slope. So the numbers will get smaller as they get to 0. The flatter the line, the more gradual the incline, the closer it gets to 0. Now, what if it starts going the other way, starts getting steeper and steeper? Well, this is where we start getting like a slope of 2, where you go up 2 over 1. So the numbers 1, a slope of 1, which incidentally is not straight up and down. That's a slope of 100%. That's the same as the number 1. That's weird. 100, 100. Yeah, 100% is not straight up and down. So the numbers get steeper and steeper to like a slope of 15. Well, what's straight up? Slope of 1,000,000 isn't there, because that would be up 1,000,000 over 1. Slope of 1,000,000,000 isn't there. So when you have something that goes straight up, like I've just drawn absolutely perfectly straight, it's almost like it's infinity. Yeah. Well, let's go the other way. You start going down, and it gets steeper and steeper, so bigger negative numbers. So this might be a slope of -1 and a slope of -3 and a slope of -5. And it keeps going, a slope of -10 or 15 where you go down 10 and over 1. Well, if you're going straight down, that's like -infinity. Oh my word. Straight up and straight down actually are the same steepness, and this is where we have a problem. These two, something bigger than a billion and less than -1 billion, can't happen at the same time. And so this is a visual representation of the problem that occurs when we divide by 0. So if you have the line x equals 6, obviously you've got like a 0.62 is on that line and 6 -3 is on that line. Well, let's find the slope. The slope is going to be 2 minus a minus 3 over 6 minus 6. That gives us 5 over 0. Plug that into your calculator and it should shock you or beat you or something, because what you just had it do was say what number is bigger than positive infinity and less than negative infinity at the same time. This is why it is called undefined. Undefined slope. And let's talk about it a little bit more. What's 30 divided by 6? Well, that's 5. That's the same thing as saying 30 equals 6 times 5. If you take 30 divided by 0, and somebody will be like, oh, I think that's 0. That is the same thing as saying 30 is equal to this bottom guy times the answer. Yeah, this should make you feel really awkward. 30 equals 0 times 0, so that doesn't work. You're like, well, 30 over 0 equals, well, it could equal something. Really? Could it? No, it can't. 0 times anything is 0. To find an answer for division by 0 is not possible because the multiplication tables of 0 are established to equal 0. You can't go backwards on it. So this is why undefined is the appropriate term. Some of you have heard the phrase no slope. I would encourage you to avoid this. The reason is, when I say I have no carrots, what does that mean? Well, that I have 0 carrots. So some people will interpret the no slope to mean 0 slope, meaning there's no inclination, there's no incline, there's no rise while you're running. Other people say, aha, the slope does not exist, undefined. And can you see how no slope might be confusing? Some people think it's vertical and some people think it's horizontal. Well, that's something I would encourage you as tutors not to use that because it's ambiguous. You either have a slope of 0 or the slope is undefined, which means it is a vertical line. All right, let's talk about equations. First one, slope intercept. Yeah, this one we've covered right here. This is most commonly written as y equals mx plus b. The m and the b don't mean much to students who haven't used it a great deal, except they can say y equals mx plus b, but they don't know what they're talking about. So y equals, you can also write it like this, y equals slope x plus yent, meaning y-intercept. That may help students to always remember that m is slope and the b is the y-intercept. Now, there is also one called standard form that you may use quite a bit. It looks like this. In the process of getting y by itself, it'll look like this. Y equals negative a over b x plus c over b. Notice that the slope is always negative a over b. Some students will find this a very helpful shortcut, that they will just totally skip that and say, oh, 3x plus 5y equals 9. Well, the slope is then negative 3/5. Go ahead and check it out, and indeed that is correct. This shortcut will always work with standard form of an equation. The other form of an equation that you may run into is called point slope. Many students in beginning or intermediate algebra have not seen this one, so be careful in using it and go off of what they have been taught in class. The point slope is where you have y minus a particular point mx minus x1. The reason this is not as commonly used is that when you simplify and get y by itself, this one is unique. Also, if you get these so that they are reduced down into relatively prime integers and you always start with positive, this one will be unique and will help you in further math classes when you start writing the equations of planes and such. This one, however, is not unique because you can stick any point on the line here and you will get another equation of that line. However, it may be beneficial when you write equations of lines. So for example, if you are given the information that we have slope 5/8 and it goes through the point 0, 2, you can write the equation of the line in three different ways. You can say, oh, y equals mx plus b. There's the 5/8 x plus, and there's your y-intercept is right there with the 2. If you wanted to do standard form, well, use this shortcut. Obviously, it's a 5x, there's our a, and then a -8 is our b, equals, and then you stick 0 in for x and 2 in for y, and you get -16. These two are the exact same equation. One is written in slope-intercept and one is in standard form. You can also do it in point-slope form, and I'll put that over here. Y minus the y value, which is 2, equals the slope 5/8 x minus the x value, which is 0. And you'll notice if I simplify that and write it in slope-intercept form, I get y minus 2 equals 5/8 x minus 0, and then y equals 5/8 x plus 2. And these are all the exact same line. Notice that they're almost equivalently easy when we're given the y-intercept. When we are not, however, you'll see a little bit difference. And let's try it this way. If the slope is -4/7 and we are looking for the point, or this line goes through the point 7, 3. Now notice that we are going backwards. For the majority of this entire process, and this may be helpful to bring up to students, they were given an equation and they were asked to find a slope, they were asked to find points, they were asked to graph it. We're asked to go backwards now. So here you would have to write y equals -4/7 x plus b. Then stick this in. So when you're writing equations of a line, step number 1, put in the slope. Number 2, put in the point. And number 3, solve for what you need. I'll show you what I mean. In this case, we have the slope, but we don't know what the intercept is. So we put the slope in. Now we're going to put the point in. X goes in for that, and 3 goes in for y. So we get 3 equals -4/7 times 7. Oh, we got lucky on that one, plus a b. Now we get to stick this point in because it has to work. Remember, going back to the beginning concept. If this point is on the line, when we stick it into the equation, it has to make it equal. So we get 3 equals -4 plus b, and add 4 to both sides, and we get b equals, oh, we got lucky, b equals 7. So then we solve for b, and then we rewrite it. Y equals -4/7 x. Now we know the b plus 7. There was slope-intercept. Now for standard form, let's do the same thing. Okay, so there's that guy. Negative a over b using this shortcut right here. So a has to be 4 and b is 7. So we would have 4x plus 7y equals, and then we stick in the point, which is 7 here and 3 there. And we get 4 times 7 is 28 plus 21 is 49. And there we have it. This is actually kind of slick if you ever start to learn this. So now let's do the final one, point slope form, where the slope is -4/7 and we're sticking in the point 7, 3. So point slope form, again, only use this if the student is good with it. So y minus y1, 3, equals -4/7 x minus x1, which is 7. Oh, can we simplify this down? Sure we can. Jump that in. y minus 3 equals negative 4/7 plus 4. And add 3 to both sides, and we get y equals negative 4/7 x plus 7. And notice we get the same thing. The nice one about this is that they can always rely on slope-intercept to graph a line or to get it in line. So it's very handy to use. And if a student is confused at those other ones, stick with this as the basic. Some will appreciate the simplicity of this, but you have to be aware not to mess up the negative sign and stuff like that. And over here, this is nice because you just stick stuff in, but you're hardly ever given an equation that looks like that to graph it. So it's really best just when you're writing equations of lines, and some students don't like the inconsistent form. In summary on these, be sure you pay attention to what the instructor is trying to teach and support them in that. Thanks.